Hello and welcome back. In this video we'll continue looking at how to modify graphs and transformations of functions. In this example, let's graph two functions, x squared and x minus 3 squared. So x squared, this is a parabola, and it will be sort of a U shape, like so. And now we'll graph g of x is equal to x minus 3. And what I want to point out right away is that g of x is nearly the same thing as f of x. F is just going to be x squared, but g is going to be x minus 3 squared. So g is the same thing if we just put an x minus 3 into f. So let's see what happens to here. If I plug in some values, if I plug in 0, if I plug in, if I plug in 3, 4, or 5, or 2, or 1, we'll get roughly the same shape, but we'll notice that it's been shifted to the right. So it's the exact same shape, but it's shifted a little bit to the right. And because we are doing this, we know that we're going to shift it 3 to the right. So in general, when you subtract a number from x directly, we're going to be shifting to the right. So let's write this down. So for a horizontal shift, when you subtract a little bit, when you subtract c from x, we're going to be shifting to the right. We can also shift to the left by adding something to x. So here, if you add a little bit to x, we're going to shift to the left. So adding corresponds to left, and subtracting corresponds to right. This may seem a little bit backwards, but if we really stop to think about it, this will make sense. So let's do one more quick example of just this. So we'll look at g of x is the square root of x minus 2. So the first thing is that this should look a lot like the function f of x is just the square root of x. So if we graph this, this is going to look like the following. Just kind of like a parabola that's been tipped on its side, but only the top half. Now, if I subtract 2 from the x values and plug them in, what will end up happening? Well, if I plug in a 0, 0 minus 2 is negative 2, and we can't take the square root of a negative number. If I plug in 1, 1 minus 2 is also a negative number, so I can't take the square root of that. If I plug in 2, 2 minus 2 is 0, and the square root of 0 is 0. If I plug in a 3, 3 minus 2 is 1, and the square root of 1 is 1. So we can see that we have shifted to the right. And again, we are subtracting, so we are going to shift to the right. And again, this may seem a little bit counterintuitive. We usually associate addition and positive numbers with going to the right, but essentially the x has to compensate for the subtracting c by moving to the right a little bit. So let's do one last example involving translations. So here we've got a function h, which is going to be x plus 1 squared minus 3. And what this looks like, if you get rid of the minus 3, and we call this a new function, this looks like an x plus 1 squared. Okay, so again, this looks like a squared function. So if I get rid of the plus 1, this looks like an x squared. So what we'll do is we'll take the x squared. If we graph it, we've got ourselves a little parabola. When I add 1 directly to the x, we are going to shift it. And again, when we add, we're going to shift to the left. So when we graph x plus 1 squared, we are going to shift to the left by And again, now we're going to subtract 3 from this. So the height of this function is going to go down by 3. So we come down by 3, and we do the same thing. So this will be something like this, and the other side will be something like this. So again, first we added 1 directly to the x, which shifted our function to the left by 1. And then we subtracted 3 overall, which is just going to decrease the height by 3, moving the entire thing down. So we can combine shifts, horizontal shifts, and vertical shifts. The last thing that we'll do in this video is we'll look at reflections of graphs. And to sort of emphasize this by drawing, by thinking about what it is that we're graphing, if we take negative f of x is going to be the height of the function. So if we negate it, we're flipping it over. Specifically, we're flipping it over the x-axis. So before I look at this next part, let's focus on negative f of x first. So when I look at the graph of the absolute value of x, this graph looks like this, and it's just this v here. If I plug in 0, the absolute value is 0 is 0, the absolute value of 1 is 1, 2 is 2. Of negative 1, the absolute value of negative 1 is 1, the absolute value of negative 2 is 2. So we get this nice v. But if we negate all these values, if I negate 0, I still have 0. Here, the height is 1, but if I negate it, my height is now negative 1. Here, my height is going to be 2, so we're coming straight down. Likewise, on the other side, if we negate all these heights, they become negative. So whenever you add a positive height, it becomes negative. And if we had any negative heights, they would become positive. So we're just flipping this over the x-axis. So all this is a reflection. And this is maybe a little bit trickier to see, but the graph of f of negative x is going to be the same as the original graph, but it's going to be reflected about the y-axis. So again, let's look at an example. So if we have g of x is the square root of negative x, well, this looks a lot like just the square root of x, but I've replaced x with a negative x. So the square root of x will look something like this. Comes up and to the right. We can't plug in negative values, so 0 is where this stops. And then as we plug in bigger and bigger values, the square root will become bigger. But now we're going to plug in negative values. So if I just think about this for a little bit, if I plug in 0, the square root of negative 0, well, negative 0 is just 0. If I plug in 1, the square root of negative 1 doesn't exist. The square root of negative 2 doesn't exist. So if I plug a 2 in here, I'm not going to get anything. I now have nothing on this right-hand side. However, if I plug in a negative 1, I have negative negative 1. The negative signs cancel out, and the square root of 1 is going to be 1. And if I plug in negative 2, I have negative negative 2. Negative signs cancel out, and I get the square root of 2, which is about 1.4. So now I have my square root function. If I could draw this, maybe I'll go backwards. Now my square root function has flipped to the other side. So instead of going to the right, now my square root function goes to the left. Why? When we look at this, what have we done? We've negated all of the x values, and x corresponds to left and right. So what was going to the right, if I negate it, is now going to the left. What was, if I had anything on the left-hand side and I negate it, it's going to flip over to the right-hand side. So, negating x, not f of x, not the whole thing, but just negating the x, will flip the graph across the y-axis.